Number 11. Draw the two resonance structures for the nitrite ion, which is NO2 with a -1 charge. Now this is a toughie. Resonance structures are very difficult. We did not cover them much in the lectures, which means they're not going to be a large part of the quiz, but they will be represented a little bit. Also, a heads up, if we didn't hit it much in the lecture, it's a good possibility it's going to be one of those things that I refer to on the quick write, but you have to learn on the fly. It might be another one of those. Just, I don't know, maybe. Heads up. So, resonance structures refer to this event when you're making your Lewis structure and something doesn't quite add up. For example, if I go over here and I make my Lewis structure for NO2 with a -1 charge, right? I have my central nitrogen. Okay, it can make the 3 bonds. It's got its lone pair up here. We're looking good. And I add my oxygen over here and an oxygen over here, but there are only 3 electrons available to bond. So that means that one of these oxygens doesn't get to form the double bond that it wants to. Remember, oxygen is bringing 6 valence electrons to the table, and so it wants to form 2 bonds to satisfy its octet. Here, an oxygen is only going to get to form, or sorry, only one of the oxygens is going to get to form its double bond. One of them is going to be stuck with a single bond. But here's the question. Which oxygen gets the double bond and which oxygen gets the single bond? That's the problem. That's the issue that we run into when we are drawing Lewis structures for certain compounds. And that's why we have this idea of a resonance structure. Because is the double bond on this oxygen or is the double bond on this oxygen? These are completely different oxygens. They're completely different atoms. How am I supposed to know which one the double bond forms with? And what we find in reality, or what we observe in reality, which is an important distinction, okay, is that this double bond actually bounces back and forth between this oxygen and this oxygen. So for a split moment, just an instance, right, this oxygen is double bonded and this is singly bonded. Well, in the very next instance, these electrons jump down here to form the double bond. These 2 electrons jump out here to form the singly bonded oxygen with the 3 lone pairs. And there's just like a switching back and forth, switching back and forth, switching back and forth, almost instantaneously. And so that's why we have this resonance. The real form of NO2 minus is resonating back and forth, back and forth, back and forth. That's why we call it a resonance structure. It's also why they're kind of difficult to draw, because the concept behind them is a little bit mind-blowing.